I'm Angela McIntyre. I work at Gartner. I cover wearable technology. I came out of the MIT Materials Science Lab, which makes materials a very fond topic to my heart. Then I went to work in semiconductor manufacturing for 12 years, and here I am covering the wearable space. Materials are enablers for wearable tech. And the innovative companies that we've met here today transport high-tech materials from Hollywood science fiction into real products. Their innovation depends on advancements in materials, in protective coatings, in conductive fibers, and then the innovative manufacturing processes that go into that. Smart materials. Smart materials are designed to transform their properties based on changing conditions around them, such as electrical impulses or temperature or light. And looking forward, it's going to be smart materials and other high-tech materials that are enabling new types of wearable devices that conform to our bodies and are integrated into our clothing, becoming almost invisible and truly putting humans at the center of computing. We're fortunate today to have our panelists, and please come up, panelists, and join us here. They will give you their insights on innovations in materials and some of the barriers that are coming in the development of wearable technologies. So panelists, as you introduce yourselves, please let us know how your company contributes to advances in materials for wearable tech.
Okay, hello, my name is Pierre-Alexander Fournier. I'm co-founder and CEO of Hexoskin. We've presented yesterday evening at the demo forum. What we do at Hexoskin is that we bridge the consumer with these innovations in materials. So we're basically integrators of these materials. And we're constantly looking for new material technologies that can be integrated into soft goods and textiles to be able to make the bridge between the software and the hardware and the garments, the textiles and the soft goods, where we want to put the intelligence necessary to be able to monitor people's health.
My name is Scott Papenfuss. I'm with HZO, and hopefully you saw our demonstration yesterday. We are about providing technology that is applied to electronics that protects them against exposure to water, sweat, even corrosive gases. In terms of the discussion today, we are about enabling, wearable devices or smart fabrics, textiles, things like that, to be implemented with electronics and to allow them to be used in any kind of environment. One of the things that we heard so much yesterday and some today as well is that when it comes to wearables, you don't want to give people an excuse to take them off. And indeed, I think many manufacturers, their business model depends on a consumer wearing a wearable as much as possible. And that's one of the things that we help enable by giving people the ability to wear them in as many environments as possible.
Hi, my name is Akseli Reho. I'm the CEO of Clothing Plus. Clothing Plus has been in the business of integrating electronics and textiles for 15 years. So we are one of the pioneers in the wearable tech space. Our focus and vision in Clothing Plus is to integrate all kinds of sensors with the textile materials and actually make the sensors disappear. As an integrator, we work with the many different material worlds. Our magic is to put together PCBs, conductive polymers, textiles, and make the package mass producible. So we don't develop the materials, we cook up the new things out of the exciting materials that are existing. So typical product, what we engineer and what we manufacture in our own factory in China, it feels and looks like a textile product, but it has a lots of electrical characteristics and functionality built in. The company name Clothing Plus, it tells pretty much what we are trying to do. We're trying to add something into the clothing, but keep the clothing as sympathetic product as it's today.
Hi everyone, I'm Kath Rogan from Smart Garment People, and I've been in the clothing industry in sports and outdoor clothing for well over 20 years now. I'm really quite old. I was around when the very first wicking fabrics arrived. In fact, I developed some of the very first wicking fabrics, the first body mapped garments, some of the first seamless garments, seam-free technologies, soft shell fabrics and that kind of thing. And I've worked with lots and lots of outdoor and sportswear brands. And in 2006, I was having a heated discussion with the customs people at Cairo, trying to get some Premier League football tops out of the country in time for a very important match. And I suddenly realized that I wasn't having fun anymore. I had staff who were doing all the interesting things, and I was arguing with customs and negotiating contracts with manufacturers and planning production schedules. So I stepped out of it and decided to paddle my own canoe. So since then, I've been working still in advanced textiles, and I do develop fabrics, and I help people to create bespoke new products and disruptive innovations by using existing and new materials and integrating them, because of my background, into clothing, helping people to build supply chains for that as well. I don't manufacture, I simply advise people as a consultant on what's out there and help them to develop the technologies that they want. Mostly, although my background's been in sports and outdoors, I now work with quite diverse clients, everything from medical devices to the Home Office in the UK for police, and the Ministry of Defence and the Defence Science and Technology Laboratories in the UK. So I have quite an odd customer base, excuse me, and I don't actually work, only half of my work's in e-textiles. The rest of my work's in other smart fabrics, so I'll work with nanofibers, impact polymers, dielectric polymers, and integrating quite different functionality into clothing that way.
Wonderful. There have been some transformational changes in materials that really impact the market and the opportunities for wearables, and some of those have to do with protective coatings. Scott, you were demoing your product from HZO, and I'd like you to do the demo, but before we get into that, I wanted to mention that I have heard that there's some resistance from smartphone manufacturers, potentially from other wearable manufacturers, to putting these types of protective coatings on their devices, because it actually will reduce sales. They get a lot of breakage, people dropping them in the sink, for example.
Yeah, those dirty manufacturers. You know, I think that within the wearable space, you see a lot less of that, again, because there's a realization that the more people are wearing these devices, in other words, the less they break down because of water or some other factor, the better. And I think you're starting to see some change among the handset OEMs as well. Partially, it's driven by the market. Greater customer satisfaction equals further sales down the road. But you also see some manufacturers, Apple, perhaps Samsung, that have an ecosystem. And selling a device is one thing, but if they can follow on purchases of applications, ad revenue, things like that, then that's just additional revenue. And obviously, if the device isn't working, then they don't have access to that revenue. There are other metrics like halo effect. You know, in the case of Samsung, if you sell a phone, does that lead to a purchase of a TV or a smartwatch, something else later on? So I think you are starting to see that change a lot.
Excellent. And there are some manufacturers that are coming out next year with devices that are more waterproof. Could you please show us?
Yeah, absolutely. So this is a Samsung S4, not the S4 Active that they bill as being waterproof, but just a standard S4 that we've coated. And if I can see where the power button is, you can see, if you come by our booth, you can see the same demo, but in the back, you can see that it's completely exposed. We coat on the inside rather than the outside of the device. And even with that, our coating is about 5 microns, and so it's typically not visible to the eye, and in fact, it'd be hard-pressed to find any sign of coating on this. But just pop that in, and
Right, I was really surprised. I expected when I saw this technology that I would be able to see a coating or feel it, and it's really invisible.
it is, yeah.
And it's put on when in the manufacturing process?
It depends on the device. It depends on the components that go in, the nature of the device, the manufacturing process itself. So it's hard to give just a clear answer. In general, though, as close to final assembly as possible is what we tell customers.
And it's a regular CVD type process, which allows you to have bigger size substrates and devices go through than some others.
Yeah, that's right.
Yeah.
Okay.
Yeah. And how is this different, or what are the advantages to this type of coating versus a mechanical type water seal?
You know, there are a number, and it's not an either-or proposition. We find that some companies that already use mechanical seals come to talk to us as a redundant solution, which is great. But mechanical seals, just like anything, will fail over time, and they'll fail for a number of reasons. Environment, they can shrink or expand in heat or cold, or just user error. So, you know, in the case of the S4 Active, or I think you can point to Sony or other companies that manufacture similar mechanical seals. Unless the user puts in plugs, they're going to fail. And they'll fail within a matter of seconds. So the protection is only as good as the user in that case. And that's a really good case for us as being a redundant solution.
Okay, great. Thank you.
Yep.
Kath, you were talking to me about a demo, similar protective coating on fabrics.
Yeah. There's I've a little demo here of my own that's not quite as cool as dunking my phone. I was supposed to have a dunkable phone, but I couldn't get it to me in time. But this is a plasma treatment, so it's a different technology, but it has a similar effect in this case. I came across this company. This is one of the technology suppliers I work with called P2I Labs in the UK. They work with the Plantronics guys and Motorola on electronics. I work with them on materials. This is a tissue from a pack of tissues, but this is plasma coated. And if I push this into the water, there's nothing I can do to actually get that drenched. This just isn't going in there. The tissue comes out as dry as it went in. Now, I've dunked that a few times actually, but...
yeah, that's pretty neat. Can I take a feel of this? It's like,
have a go.
So this is the one you dunked. And,
yeah.
Well, it's a little wet, but it's, you know what, tissues when they get wet, they fall apart. This is like very strong, and it's just surface water.
Exactly. And what it's doing is lowering the surface tension so that oils and waters won't stick to the surface. They'll bead and roll off. Now, the applications I work with on that for are chemical biological protection. So for instance, mustard gas isn't a gas, it's a liquid.
Oh, okay.
And you want things like this and chemicals to be able to roll off rather than stay on the garment and potentially permeate and cause troubles. So there's quite different applications for this, but you can also put different things into the plasma mix. So we can put reactive agents in there that will potentially detoxify nerve agents or biological contaminants. So there's multiple applications for that kind of product.
Okay, so if you had this, it's like you could have it in a chem suit.
It was originally developed, by DSTL, by the MOD in the UK for chemical biological protection. But in fact, because it works in a vacuum chamber, it's not particularly suitable for treating finished suits.
Right.
It's just, these are large objects into a vacuum chamber. It's great for things like headsets and small electronics. It's much more commercially feasible there. So now we're looking at batch processing fabrics in those areas.
Right. Thank you. When we are looking at new kinds of garments that incorporate sensors, many of those will have the sensors that detect the toxin in the atmosphere. So you can also have a gauge of whether or not you've been exposed, and then have a suit that can keep you safe. Wonderful.
Exactly.
So incorporating different types of fibers and coatings on fibers has enabled electricity to be kind of electrical currents being visibly sewn into our garments. And I was hoping, Axeli, that you could talk a bit about the fibers themselves in your Clothing Plus garments. How are they made? How do they actually conduct?
There is actually quite many conductive fiber types, conductive materials that we are utilizing in our environment. There is a conductive polymers. There is a metallized textile fibers. There is a carbon fibers, and there is purely metal-based fibers, for example, stainless steel fibers. And all these materials are feasible in the integration environment, what we are having. But I see that all these conductive materials, they are the base for the whole smart clothing and functional clothing industry, because it has been the major enabler to start building the electrical functions in the garment. Of course, there is a chance to laminate or put together textiles and flexible PCBs to make the things to happen on the same track, but that's more demanding to do machine washable PCBs than machine washable conductive fibers. So I see that it's the stepstone towards more functional world. The conductive fibers is the stepstone, and in the future, I believe, and I already see that the flexible PCBs will become machine washable against the chemistry and the mechanical stress that washing machines, for example, generates, and the wearing generates. That probably the PCBs will have a big role in the future. In the smart clothing.
Yes, well, you mentioned washability, and Pierre, with your garments, that certainly is something you considered.
Of course, it was a major constraint. The garment had to be machine washable in a regular washing machine. And, we solved a lot of problems to be able to do that.
Like what kind of problems might come up? Did it affect your selection of the type of yarn, or?
Well, a washing machine is a very harsh environment. We did some project with the National Defense and the people working with textiles for defense, and they were saying a washing machine is a harsher environment than where we were sending the soldiers for the clothing, because there's heat, there's humidity, you have soap, you have and it's not only soap, you have enzymes and all sorts of products that make your clothes clean in this machine. So it's really harsh for the garments. And this is actually one of the things that shortens the life of your regular garments the most, the washing machine and the soap, and too much soap that people put in the washing machine. So one of the considerations we need to look at when we make smart garments is it has to dry, all the components, all the electronic components have to be able to dry correctly, to not oxidize and not be affected too much by the washing machine. The goal is that the smart part of the garment has to be more robust than the garment overall. It has to survive the garment, basically.
Thank you. Exceli.
Yeah, the washing is very typical treatment what people are expecting to do for their clothes. And what we have learned since we are shipping globally is that even the washing machine is not a standard thing. There is a dramatically different waters in the world, dramatically different chemicals, dramatically different mechanical methods to run the machine. The temperature range is enormous, so it's really demanding to kind of say something that this is machine washable globally. It's a challenging environment, especially if we take somebody from the electronics industry, like a Freescale, and ask them, is this machine washable? Probably they are very allergic on the question like that we don't have a clue.
Right. Well, Kath, you work in the textile industry, well, with textile suppliers, and you have some prototypes to show us of their samples of materials and fabrics that have integrated electronics in them.
Yes, as I said, I advise people on how to develop new technologies and make them wearable. So I am always scouting for new technologies, and in fact, that's what I'm doing here. I'm not on a sales pitch, I'm looking for new technologies, and if you have things that you think I'm going to find interesting, please talk to me. I rarely ever use a technology in the way in which it was invented, but occasionally I do. And the suppliers I work with, I don't represent anybody, by the way, that's how I can remain independent, but they often say I'm the best sales rep they never paid. Because I expose their products to various people and potential clients. Now, what I do is look at these as enabling technologies. It's a little like the smartphone. Until all of those microelectronics devices were packed into smartphones and app developers could imagine hundreds of thousands of applications for them, who knew we could do anything other than make calls? So what I try to do is inspire my customers by saying, look, what if? What do you really want to achieve? What's your vision? And then I have to manage their expectations and roadmap the technologies to get there. So some of the things that I could show you, for example, here are some LEDs integrated into fabric, if I can get this to work.
This fabric looks like a lace.
This is Foster Rona, or a Swiss embroidery expert company. They make massive embroidery machines, and they do an awful lot of embroidery for lingerie. So they work with extremely delicate fabrics up to very high-end industrial fabrics for the automotive sector. Now, as I said, this is really an enabling technology. It just shows you that what they did was they took standard technology and then they inserted LEDs in the same way that they'd insert sequins. And we use conductive fibers to be able to make these things work. But those could be LEDs, or they could be thermistors for temperature sensors, or they could be effectively in the future printed OLED devices. So the embroidery really is the enabling technology. They also, we can do infinitely different things with embroidering sensors, embroidering antennae. Embroidery is just one way to do it. There's lots of ways to get smart into the garment. This is a heating application. These are heating yarns that are applied to the garment. And in terms of lighted textiles, there's some existing technologies that are already commercially available. This, for example, is, some of you might recognize what the product is, given that we're in Hollywood. These are the people who produce the Tron Legacy garments.
Colors.
Now, this is electroluminescent fabric. Now, these are printed and applied. The guys have developed their own way of creating connections because they had to, so that they could make it easy for people to integrate it into fabric straight away. So there's immediately available products. There are immediately available products to be adapted, and there are emerging technologies like printed OLEDs coming over the hill, where things start to get really, really interesting because the power usage goes down dramatically, and the potential for things like wearable displays when you put in active matrices become incredibly interesting.
Right. Yeah, this one, it has different colors, and when I saw it flat on the table, I thought these would be kind of thick pads, but no, they are just
super thin and flexible.
Thin plastic polymer. Elastomite. Now, the connectors between them are just as flexible, But they look like they're again covered in the polymer. And how does this hold up?
Well, these are standard technologies for textile companies. So the easiest way to integrate things right now is to use existing technologies. So these are heat-bonded fabrics, heat-bonded polymers. It's exactly the same process that you use with a flatbed press to put on branded logos and heat-sealed logos. So it's the same type of process, and they've just applied it in a different way to achieve something quite unique and easy to integrate. But this is effectively how printed organic electronics and printed OLEDs will be in the future, when we can get rid of the issues around encapsulation and some of the production issues. You know, those things are going to be the next generation of lighted textiles and wearable displays.
Right, yeah, so have the display right on yourself, be able to program it so you can change the picture.
And to be able to wear your display on your sleeve, I mean, for the military, that's incredibly important as well.
Oh, okay, yes, I hadn't thought about that. So you could have, so the OLEDs would help that, and the flexible.
People are already developing that. Philips and there's a US corporation called the Flexible Display Corporation who are working with Philips on doing that, and working with the American military right now.
Right, I've talked with a couple companies myself. One is Cambrios, and they're able to use a flexible polymer substrate, and then they kind of put on the conductive layer as a paste that has overlapping silver fibers. It could also be conducting carbon nanotube fibers as well that allow the touch. Right. Did you have another?
Just as these are the more emerging technologies. Effectively, what often happens when I go to see clients, occasionally I get people who kick my tires, and they're usually the really big businesses, and I bring stuff to show them and inspire them, and then I write them a proposal, and they say, we gave that to our design department to do. Well, here's the thing, you know, these are existing technologies. If you Google, you can see what's happening right now. But I work with these people very closely to develop new applications. So when I work with people, they see what's next. And this is one of the things that's next. It doesn't look very exciting, but you know, I'm seriously excited by this. You know, these are flexible electronics encapsulated, and what this company have done, well, actually this is a research institution. This is IMEC and the University of Ghent. And they've worked with a laser cutting supplier so that when you can't see the conductive fibers because the conductive yarns, because they're buried in the weave, an electronic eye can locate those yarns just in the same way that we'd normally use the electronic eye in the laser cutting process. It'll then expose the conductive element and place the fabricated, pre-encapsulated flexible electronics exactly where you need them on the garment. So again, it's existing production technology and techniques, and they're kind of, just like these guys in embroidery, they're kind of hacking them and developing them to incorporate new technologies. So this is something that it's not going to be commercial for at least 18 months, maybe 2 years. There's more development work to do there, but you know, that's the kind of thing coming over the hill.
And each of these is a different color.
Oh yes, I should switch it on actually. It's much more impressive when you see that it works.
Yeah.
They just use OLEDs to demonstrate the conductivity, but these could be any microelectronics device.
But you said also something interesting in how they make this. You have the conductive fibers embedded in the cloth, and then you're able to find where those are using some sort of vision system. So you might even have cloth with these fibers and then retroactively decide what to do with it, where to place the lights or the sensors. And do you see that as an enabler for garments going forward, or?
Well, yes. Well, this is necessary work, but at Hexoskin we feel there's an underinvestment in the manufacturing capabilities. And this is an opportunity for investors, I think, and for companies that work in the field like Clothing Plus and MC10. Right now, most of the processes to put conductive fibers and smart materials into the garments are labor intensive, and the development cycle for new product is very long. So Kat was talking about 18 months for just wires to be able to light up the lights. And we're still, in the industry, we're still figuring out how to make two wires cross each other's. And most of the intelligent materials we put in these garments are conductive wires. So basically, it's just power lines and wires connecting sensors. So we feel like the textile industry and the soft goods industry needs new machines to be able to make these new products we want to make. There's demand for these products. The infrastructure is there to connect these smart garments to the internet. So everything is ready for this to happen. But there's a gap between all the smart materials that we already have and the companies that want to make products. There's a manufacturing gap. And we need companies that are able to invest the capital necessary to develop these new machines and provide all the people here these new materials in a way that is cost effective for new products.
Axeli, you have a large manufacturing operation in China.
Yeah, we are already doing millions of textile integrated sensors for very demanding customers like Philips, Lululemon, Garmin, Under Armour. So we have already solved the way and proved the way to scale up the production where textiles and electronics, the sensitive sensors are put together. But I follow completely the theme what Pierre brought up, that there is a room for the major innovations and investments in this place, because it's still a big challenge to put together the thinking from the electronics industry and the textile industry in the same factory. For example, the life cycles and how the labor intensive the things are. The textile industry is still very labor intensive because the designs and the models are changing so fast. The shapes and the sizes are constantly living. There is no room for the automatization in that industry. But on the other hand, the electronics industry, all the tolerances and requirements, the quality requirements are pushing the automatic manufacturing into the picture. So that's actually a huge space for the future innovations who really figures out the clever way to fit these two worlds together.
You know, if I can just say that there's a precedent for this, which dates back quite a long way, when NASA were developing the first spacesuit, and the company that they brought in was Playtex. And NASA employed Playtex to help them develop this suit, and there were a bunch of engineers working with lingerie people. Now, lingerie and a bra is just the most heavily engineered textile product that there is. They're very, very skilled people. And NASA just simply kept firing Playtex and then rehiring them, and then firing them and then rehiring them. Because in the end, they simply had to work out a common language. Yeah. You know, they couldn't, the engineers and the electronics people couldn't cope with their lax attitude to tolerances. And the way that they developed by making stuff, seeing if it worked, trying it again, and constantly iterating. So it's a language issue. It's a language barrier that's existed for a long time. I have a colleague who works for a company called Intelligent Textiles, and actually they already commercially produce these 3D woven fabrics. They've got patents just about everywhere, and they're working with the military. You know, they have a textile designer and an electronics engineer who work together, and Stana and Asha, they're called. And Stan says it's as though at about the age of 7 or 8, we stopped talking to each other and developed our own languages, and now we're having to learn how to talk to one another. So it is an issue. It's a communication as well as a cultural issue. And I find, I don't know about you, actually, the easiest way so far is to try to put as little change into the process as possible. If I can adapt an existing process that people are comfortable with in a textile factory, then that's the first hurdle. Once they get a little more comfortable with the fact that they're dealing with electronics, I think they'll be willing to go further.
Yeah, that's a good thinking. And actually, the question is as well that what is the right factory to start kind of learning? Should we start learning the electronics industry to think like the textile world, or the other way? We have made it quite brutally that we established completely new factory and brought the things from the both sides, but it has took more than 10 years to make that machine really oiled. and working. That's a very multidimensional challenge that is existing on that.
I think you're right, and I think you see plenty of siloed thinking just within electronics manufacturers themselves, but I also think that just the short life cycles of products in consumer electronics in particular really makes it a moving target that it's got to be hard to adapt to for textile manufacturers.
Yeah.
Well, having said that, in textiles, we're used to working to seasons that get shorter every year. We're used to short runs and switching styles, switching materials. Textiles and garment factory are used to adapting very quickly, but they're used to adapting using existing processes. Right. So moving them on to using brand new processes and new quality controls and new components, they're a little nervous.
Yeah, and I'm not sure where it comes from, but so far what I have learned that actually the textile factories, there is a lack of braveness to invest. I don't know, is the relationship so short, or but I've got so many comments that the textile manufacturing sites are always a bit afraid on losing the next season deals, and the manufacturing would be moved to next country on next year. So there is no long-term thinking on that space.
And well, it's an industry that is very competitive. Margins are thin.
Yeah.
They don't want to invest more than it takes in capital. But what we need to be able to have normal clothing that feels normal, like the clothes you're wearing today, to have in them the equivalent of all the medical devices you would like to have for constant health monitoring, to have something like a dashboard of your health, and that's something very precise. We would need in the textile industry a breakthrough like the integrated circuits were a breakthrough, and the transistor was a breakthrough in the hardware industry. And this has not happened yet.
I also wonder if, in the previous presentation we saw the Necklomimi, you remember. In looking at that, I wonder if a similar kind of product where you look at it and think, that is the dumbest thing I've ever seen. I've got to have one right now. You wonder if something like that couldn't drive that as well.
Well, maybe, but it's going to stay marginal. I think it's going to stay a niche. But I think what people are looking for is to be able to buy a normal shirt and pants and underwear, and normal-looking things, but that are kind of magical because they record your health history and they can communicate with the network, and then you get software health services back because you're wearing these type of clothing. And clothing brands are really open to that, but they're looking for the manufacturers who can mass produce these products. And we're already making millions of units a year, but we need to be able to produce billions of units a year, and it has to be even cheaper than today. And we need to work with a lot more smart materials than we do today.
Good point, Pierre. And I'd like to ask of our panelists one last question, because we do want to leave time for the audience to ask questions as well. So if you each would like to let us know what you think some of the major obstacles are that need to be overcome within the next 5 to 10 years, and how will the wearables industry or wearables products be enabled if we can overcome those hurdles? What new things can we see?
Well, a lot of people have talked about power today, and I think it would be really nice if we would have fibers that would produce power. We don't need that much, and a lot of people come to me and they say they have an energy harvesting solution, but they're talking about microwatts. But if we could use all this surface, all this area to produce power, we could get to produce maybe 50 or 100 milliwatts, and that would be enough to enable a lot of applications.
Could it
you wouldn't need to recharge batteries anymore.
You wouldn't need to recharge batteries, but maybe even top up your smartphone or keep your watch charged, things like that. Interesting, yes.
For me, I think that we heard some talk about where's the best place for wearables. Is it on the wrist? Is it up here? If you're unlimited by power, or other constraints, just think about where you can put sensors throughout the body and the things that you can do with that, especially in a form factor that doesn't look strange like you just mentioned. That's what I look forward to.
Actually, it's my point of view is not the material science. I see plenty of already existing components available, and what I see from here to the future, what happens after a couple of years, all the soft batteries and interesting new materials to be available. More than that, I see a challenge that the companies are not brave enough to dream what they want to have, because my favorite job or part of my job is to get a dream from the customer which looks almost impossible and bring that to my engineers who almost screams to get the chance to solve and develop something extremely meaningful and cool. So I'm sure that the materials will meet the dreams if the dreams are good enough.
Well, again, looking to the future, I think one of the more interesting directions is when we start moving away from just sensing and we actually put actuators into garments. In terms of even just sensing, I think that Pierre is absolutely right that some of the people that I'm talking to now, where it's getting interesting, is where you don't actually want a sports device. If you want to monitor yourself, what you want is to be wearing your most comfortable bra or have something in the waistband of your Calvin Kleins. That's where, hopefully, the sports industry is paving the way and wearable tech is paving the way for people to be able to accept these devices more readily when they become available. But where I think it gets really interesting is when you start to augment performance. So you could use dielectric polymers, whether it's for energy harvesting or whether it's for having a wearable workout. You know, these are the dream products, you know. These are the things that we really want to do. And we can see the enabling technologies in order to get there. It's just going to be a few years before we get there, because partly it's the demand and partly it's the amount of investment.
Yeah.
Wonderful. Let's thank our panelists.
I just wanted to continue on, because that was going to be my question, which is what sort of other outputs, other than other than connectivity, what other sorts of things you see as potential outputs for garments? Can we potentially change pigments? Can we change elasticity? If stiffness, we move them. What can we do potentially coming down the road?
I'm going to repeat the question so that everybody can hear, hopefully. Is what's coming down the road that are new outputs for wearable tech, whether it's changing pigments or flexibility?
Well, if I can start there, those things already exist. There's lots of chromic materials around. The issue tends to be that that's color changing, for example, or thermochromic materials. If those types of dyes respond to heat, I mean, I've looked at this for adaptive camouflage, for example. When we put a conductive current through a garment, we also generate some heat. And that could be used to control the pigments and the placement of patterns. It's already being used in wall coverings and textiles there. So, for example, you have a print of a nice picture on your wall covering. As the sun hits it during the morning, flowers start to appear and that kind of thing. So chromic materials are already available. It's people coming up with the dream applications that we love to hear, because we'll think, yeah, okay, well, either we can do that right now or we know how we can do that.
Yes, sir.
We work on genetically modified natural fibers that are amenable to electronics applications. So the cotton that had different conductivity properties, or wool that perhaps has some special characteristics compared to sheep roast or
Wow, what an interesting question. It's about genetically modified organic products or natural products. So,
Same.
if I can't get an electronic cotton garment, why not?
Okay, you could. You might not do right now. Some of the most interesting things in materials aren't actually the core materials themselves. They're the finishes, the finishing applications, whether it's plasma or the kind of planar finishes that we were talking about there. But traditional wet finishes are getting even better with some really clever chemistry. There are already people who are applying carbon nanotubes to cotton, for example. We can electroplate or plasma coat cottons and wool fibers to make them conductive. You might not want to do that. It's a particularly expensive way to do it. But it's the finishing processes. There's also an awful lot of work going on in cellulosic fibers and in, say, bamboo fibers, for example, because people are quite concerned about using polymer-based fibers that are oil-based. The environmental lobby has grown to such an extent that we're not just looking at organics anymore, we're looking at replaceable and renewable materials. So yes, we're also looking at ways to make those smart and conductive. They're not commercially available right now, but there's an awful lot of work happening in that area.
Other questions? Looking for hands? Yes?
So the question that always comes up with all these materials are cleaning them. That's been what's held a lot of it back. So where are we actually cleaning these fabrics?
The question is about cleaning the fabrics. We did talk about putting them in a washing machine. What are some other ways to clean them, or hurdles, or what do we see?
My answer is a bit simple. We count on the washing machines. Though every household has a washing machine. People are used to use washing machines. They have the processes for that. So what is our challenge is to choose the materials and the structures and the assembly methods that will go through the washing machine. So we shouldn't build any extra behavior around these products. We should fit those in existing environment.
And I just say, actually, with the military products, when we're testing them, I developed a blast protection for Under Armour, not the brand, wearing Under Armour, I should say, for the UK military. And I said, now, do you need me to get it wash tested? They said, we'll do it ourselves, because they wash test in field conditions. They do it in a cement mixer, which has its own stresses and challenges.
Wow. Is that the way it's done in the military?
It certainly is. You know, you're given your laundry bag and your tag, and it gets thrown into a cement mixer with regulation MOD washing detergent. So at least I know what they're going to be washing it in.
Mm-hmm. Other questions? Yes.
What sort of application areas are you seeing for smart clothing? Apart from, I mean, the obvious ones like monitoring, like you guys do, some fashion elements, and then maybe some, more tourist stuff like military applications. What else is there?
Yeah, so he's looking for additional applications for smart clothing beyond health or fitness monitoring.
Well, there's the security application. So all the lights you see on these samples, they can be used for garments that are used, for example, in airports, policemen, people working in dangerous environments that needs to be signaling stuff or need to be seen. So the protection and security is one of them.
Yeah, but also the infotainment, the entertainment things, gaming, plays, fashion, as you mentioned. So we see the world as a market, that there is the professional safety market, there is an infotainment market, there is a sports market, and there is a medical market. And on all these markets, there is 4 application levels. One is illuminated clothing, one is heated and cooled, kind of ventilated clothing. One is haptic clothing, that is somehow giving the feedback on the clothing, and then there's sensing. So all these 4 can match all these 4 in our thinking.
Mm-hmm. And also for fall detection, if you're wearing a garment that can have sensors on it, can tell whether you've fallen or not. And there's a product you have for
Oh yeah, I forgot that.
over there. Yeah.
Yeah, I brought some impact polymer along as well. You know, this is the kind of thing that people are already putting onto electronics in case you drop them, but you're absolutely right. This is a basic knee pad. This is a polymer called D3O. And the guy who has the patent on this and invented the stuff, it's actually silly putty. And his patent involved stopping silly putty being a shear thickening fluid that just spreads and in making it into something that you can form into products. And he used to demo this. He used to go along to conferences, and Richard would put a beanie hat on and smack himself on the head with a shovel, which is quite disturbing, but very effective. So these kind of impact polymers, they work in the same way that cornstarch does. If anybody's ever done that and put really thick cornstarch together, it's a fluid until you smack it and then it instantly hardens. Well, this is exactly the same polymer. It's soft and flexible until there's an impact, and then the molecules lock and it becomes instantly hard. So it's, you know, used in sports and military applications already, but it's also used for stopping your very expensive electronics from getting damaged when you drop them.
Wonderful. And I was seeing products that are for older people when they fall and don't want them to break their hip, but actually having pants that are made out of similar types of
those products already exist with this in. You know, they
Like
put
those
them in
in?
as hip protectors for exactly that purpose, for medical. I think in the medical area, there's even more interesting applications for management of long-term chronic healthcare conditions when we start to put microelectronics into yarns, which again is already happening. People are saying it's commercial. I kind of don't think it is. There might be a spin-off company. It's not really commercial yet. But you could put thermistors into the yarns so that you're knitting socks, for example, that might warn people of neuropathy damage and that kind of thing. So, and as I say, I think the more interesting area is when we start to get away from just sensing and turn things into, you know, you sense there's a problem with your glucose levels, well, you can actively deliver it through your clothing.
Well, thank you. Fantastic applications to come, all based on advancements in materials and how to put them together. Our panelists will be available to take further questions, so please come up and talk with them after this session, but let's give them one more round of applause.